Good afternoon, everyone. My name is Cyril John. I'm an applications engineer here at Heat Pipe Technology. I wanted to thank everyone for attending this webinar. Today we'll be discussing about our dehumidification product called the wraparound heat pipe. So we're going to go a little bit over some theory, just introduce you to the technology, as well as go through the main portion of it will be to use our design software SelectPlus, which I hope most of you already have user accounts for. Before the webinar started, I did send out a lesson plan for today that we'll be using as a basis, where we have 3 examples shown here, and I also have the link to that lesson plan in the comments section. So I'll continue to send that throughout the presentation so you could download it and follow along. I also, at the end of the lesson plan, I kind of have a take-it-home example that you could do for fun based on what we learned today in this webinar. So like I said, I wanted to do a little bit of theory, so let's go ahead and get started. So again, the majority of this presentation will be about our SelectPlus design software that we released a little over 2 years ago. We have about 2,000 users, and we're fortunate to have that many people interested in our technology. It's a very revolutionized how we select and design our systems. Before, it was all computer-based and really wasn't that user-friendly. But this software, we hope that once you start using it, you'll be able to select our technology much quicker, be able to output economic analysis, output submittals, reports, which you'll all see today. But before we even get to that, I just wanted to talk about what a heat pipe actually is. Many of you, if you're not familiar with the technology, a simple concept, it's basically, in our case, a copper tube filled with refrigerant. We use R134A or 410A. And what happens is that refrigerant is added to that copper tube, and that heat is added on one end, which in this case, in this picture over here, is showing on the right side. That refrigerant changes phase from liquid to vapor, flows to the other end of the heat pipe, and releases that heat. And when it releases that heat, that refrigerant changes phase back from liquid to vapor and flows back to the evaporator side, which is the right side. So essentially, it is using that phase change to absorb heat on one end and release it on the other end. Now, it's actually a fairly simple concept. It's used in multiple applications, not in various industries. NASA, for example, uses it in its satellites. So when a satellite is sent to space, you'll actually see miniature heat pipes on the control panels of the satellites. So when one end of the satellite is facing the sun, the other end is facing kind of the coldness of space. To keep that thermal equilibrium, you see heat pipes added across the satellite to keep their control boards from frying and freezing on both ends. So it's a fairly simple concept. You'll see it in your computers as well. But we just take this simple technology and apply it to commercial HVAC equipment. Now, since this presentation is about dehumidification wraparound heat pipes, you really can't go into that topic without at least mentioning ASHRAE Standards 62.1, where it basically says that you have to design your air handler to maintain a space relative humidity of less than 65%. The catch being that you have to maintain it at an outside air design dew point and mean coincident dry bulb with a space solar load at 0. So basically, your basement condition is a warm, rainy day. So you have to design your air handler without any solar loads or loads in the space to maintain, dehumidify, and deliver a temperature that is below 65% relative humidity, which is kind of very hard to do when you're designing your conventional air handler. And this is what you see here. So let's just take an example, an 80-degree day going into an oversized cooling coil. So you're trying to wring out as much moisture as possible. So you're taking that 80-degree air, cooling it down to 52 degrees, 95% RH, so you're really dehumidifying, you're really pulling out quite a bit of moisture. But you can't really deliver that to the space because you won't be able to meet that code. So you have a reheat coil downstream, whether it be electric reheat, hot water, natural gas, or you take that same 52 degree air and heat it up to 58, 65% relative humidity to meet code and to deliver a nice warm air, comfortable air to the space. And the problem with this method is very not cost efficient because you're oversizing your cooling coil on the front end and on the downstream end, you're adding reheat. So you're spending money on your cooling costs, as well as in the form of reheat, like I said, electric reheat, hot water, or natural gas, whatever you prefer in your area, which this whole method isn't really energy efficient. And it actually is not, you're not going to meet code by doing that methodology. If you look at ASHRAE Standard 90.1, it actually says that you can't simultaneously cool and reheat the same airstream, with the exception being that reheat that you use is site recovered. So site recovered meaning condenser heat for your DX systems. You could also use site solar energy, or in our case, a wraparound heat pipe. So this is an example, a schematic of a simple wraparound heat pipe, taking that same 80-degree outside air example, where you're taking that 80-degree air, it's hitting the first heat pipe, which is our pre-cool heat pipe, and that air is being cooled down from 80 degrees down to 72. So physically what's happening is that refrigerant is changing phase, again, from liquid to vapor, flowing around the cooling coil to the second heat pipe, which is the reheat heat pipe. So instead of your cooling coil seeing 80 degrees, now it's only seeing 72. So you're allowing your cooling coil, by reducing the load, you're allowing it to obviously save on your cooling costs or even further dehumidify. Now, the energy you captured upstream is transferred downstream in the form of reheat. So that same 50-degree air, which is even further dehumidified, is going to heat up to 58 degrees. So now you've delivered your design, your MET code, both 62.1 and 90.1, with using a wraparound heat pipe. Now, what's nice about this style of system, it's completely passive, as well as it's the only energy recovery device that affects both sides of your cooling process. It pre-cools before you get to your cooling coil, as well as it provides reheat as well. Now, what's driving this system is the temperature between the outside air, the temperature difference between the outside air and the temperature leaving your cooling coil. So you have about a 30-degree delta T here, which is what's dropping this temperature down to 72 and heating it up to 58. As this temperature gets larger, that performance goes up. As it goes lower, that performance goes down, hence being a passive device. So what's driving this system, again, is this 80-degree outside air and 50-degree air leaving the cooling coil. Now, psychrometrically, what's happening is you see this point A to B, which is what's our pre-cool heat pipe. So instead of your cooling coil starting at point A, now it is starting at point B. So now your cooling coil is going to dehumidify that air, bring it down to 50, so basically ride down the saturation line. And that energy you captured between points A and B is going to be transferred to points C and D in the form of reheat. So you've increased the dehumidification capability of your cooling coil, as well as you captured energy upstream and moved it downstream, affecting both sides of your system. Now, some of the applications that you see a wraparound heat pipe before, any system you have out there that is using any form of reheat to control humidity. Essentially, a wraparound heat pipe, if you're designing an air handler that has some sort of electric reheat, hot water, or natural gas, adding a wraparound heat pipe is essentially a no-brainer. As well as it allows you to improve your indoor air quality. By allowing you to further dehumidify your air, as well as providing free reheat, you're able to get better indoor air quality as well. When you're designing a system to deliver neutral air, you see this in hotel hallways, where you're trying to deliver, let's say, around between 68 and 72 degrees. Add a 3 or 4 row wraparound heat pipe is a very good application. It will limit the amount of reheat that you need to use. Again, what drives the wraparound heat pipe is the temperature difference between your outside air and the temperature leaving the cooling coil. So if you do have a high percentage of outside air, you will again have a bigger delta T, thus increasing your heat pipe performance. As well as if you have a system, a dedicated outside air unit that's completely dedicated to actually handle your outside air before delivering to your normal conventional air handlers, adding a wraparound heat pipe will allow you to further dehumidify air by reducing the load on your cooling coil, as well as providing you that site recovered reheat as well. So now let's go into our examples. Again, this is the lesson plan, and if you would like to download, please look in the comments section or in your email where you'll see a link to Dropbox of this particular lesson plan. So example 1 is what we're going to go over first. The project name is University of North Carolina Student Center, and I have a schedule here, HU1, HU2. It looks like 2 air handlers, 5,000 CFM, 5,500 CFM, and it looks like the wraparound heat pipe needs to have stainless steel casing as well as an epoxy resistant coating. And you'll see that based on the notes in this section. So the first thing you want to do is go to our software, which is heatpipeselect.com. And if you don't have a user account, I would encourage you to request one by just clicking this button right here called Request a User Account. So go ahead and type in your username and password and click Login. Here's your dashboard screen. You'll be able to see all the projects you've previously worked on, and you'll be quickly able to jump right back into the project by just clicking this Open Schedule button. It kind of looks like a calendar. You can also click My Projects, which is where you go to create a new project. You have announcements, administration, as well as I want to highlight the help section in which you can download the user manual, as well as we're consistently uploading tutorial videos. So if you click this link, you'll see our YouTube channel that has case study videos, how-to videos. So the other product that we'll not be discussing today is our side-by-side energy recovery heat pipe. And we have several videos on our YouTube channel on how to select an energy recovery heat pipe as well. And it really walks you through the process, as well as it has application-based videos, so designing a controllable heat pipe, neutral air, kind of tidbits on how to share projects. So this is all here. Again, the videos are between 3 to 5 minutes, so they're really easy to watch. And we're consistently adding more and more videos. So if you don't feel like reading the user manual, just click that tutorial video link in the help section and you'll be able to watch some videos about how to actually select a wraparound or a heat recovery heat pipe. So let's go ahead and get started, and you can do that by clicking My Projects. And for the new project name, let's type in University of North Carolina, so University of North Carolina, SC for Student Center. Let's keep it simple. And click Add New Project. And here you'll see the project name as well as the description. So this is where you would input all the project info for the project. The only thing that's really required is the project name, but anything else that you put here is really just for your benefit. So basically, if you have to go back into the project to read more about it, or if you want to kind of a refresher on where the location is, the rep you're working with, the engineering firm, any other notes you have, because what's nice about this software, it's really a personal database of your projects, so that whenever you'd like, you can go back into a project you work on 3 or 4 or a year ago. You can actually go back in and change those selection, and it's all stored there. And if you want to learn something else, or you kind of want to know more information about your project, you just click the project info button and it'll have all your notes in this section. So for the description, let's just say it's building a residence hall. Let's keep it simple. Project type, it is educational college. And my units are IP. Let's keep it in IP. You can also select metric in liters per second or meters cubed per hour as well. But let's stay at IP. And if you click Update, you'll see that the project you just created is added, University of North Carolina Student Center, Building A Residence Hall. To start your selection, you want to click this Open Schedule button. When you click Open Schedule, this is your project schedule screen. You'll have 2 product types you can select, the wraparound or heat recovery. This lesson or this webinar is on the wraparound heat pipe, which we saw in the presentation. The heat recovery device is our other product where you see similar to a supply exhaust air tunnel where you're recovering heat between the 2 air tunnels or inside your air handler, side-by-side energy recovery device. You just select heat recovery, and you'll be able to select that product. And that product is called our HRM or heat recovery module. Well, let's go ahead and stick with the wraparound, which in this case the model is DHP, and click Add New Line. And you'll see that a line has been added. Now what you want to do is click the Select Item button. And for the unit tag, let's go back to the PDF. It shows AHU1, 5000 CFM, 9075, 5049 leaving the cooling coil, and I want to reheat up to 62.7, 54.6. So let's go ahead and enter that info. So this is your input screen where you're able to enter the tag, which is AHU1. Our tube diameter is always 1/2 inch, so it has a drop down there, but there's nothing there to select at this point. The fin material, if you have a job that requires copper fin, let's say it's in a corrosive environment and you want to use copper tube, copper fin, you can do that. But for this job, the job only calls for epoxy resistant coating, so we could do that by just clicking the down arrow on the coating and selecting Electrofin E-Coat, which is our epoxy coating that we offer. The refrigerant in most cases is R410A. You can also use 134A, but for most applications, 410A, you'll see that it performs about 1 to 2% better as far as performance goes than 410A. The fins per inch that you see here is, you can change it, defaults to 12 if you're trying to hit a certain performance. The air type, you could choose between standard and actual. You could choose actual if you're entering an elevation. So for this example, let's stick with standard. And the next example, we'll go over the controllable wraparound heat pipe. So that's where we add actually normally open control valves to every circuit so you can actually modulate the performance of the wraparound by making it a controllable wraparound heat pipe. But let's go ahead and keep this one as a standard non-controllable. We'll come back to this in example 2. So for the fin height, let's put the fin height as 35, fin length as 50. Airflow was 5,000 CFM, which is shown here. Dry bulb 90, wet bulb 75. So this is the entering conditions. This is 100% outside air. You can also, if it's a mixed air system, you can actually click Calculate Mixed Air and enter the outside airflow and the temperature, return airflow and the temperature, and it'll actually calculate the mixed air temperature for you. But since this is a 100% outside air system, let's go ahead and keep it at that way by just clicking the drop down in 100% outside air. The dry bulb temperature leaving the cooling coil is 50, wet bulb 49.25. You can also change the span. The span is the distance between the pre-cool and the reheat, inside to inside, and it defaults to 12. But if you'd like to increase this, let's say if you had kind of a large separation between each coil, let's say you had 18 inches here, 20-something inches here, for cleaning purposes, you could change that span dimension to based on what your air handler span is, or that separation between the coils is. Now it is limited somewhat based on the fin length because we do have a max circuit length, but the program will stop you, let's say if you try to enter a 100-inch or 130-inch span, it'll give you some error message saying that you need to reduce the span. So for this example, let's just keep it at 12 and hit Calculate. So this is your performance data output. You'll see that the 90-75 degree air is being cooled down to 77.5, 71.4. So you're getting at about 12.5 degree delta T between your outside air and the pre-cool heat pipe, the temperature leaving the pre-cool heat pipe. So now you're leaving your cooling coil at 50.49 and you're heating up that air to 62.69, 62.7. And if you look at the schedule, that's exactly what we're looking for. So we're good at this point. You can also click psychrometric chart to view the psychrometrics of this, 90 to 77, cooling down to 50, heating up to 62.7. You can also run an economic analysis, which we'll go over in example 2. But for this one, let's go ahead and click continue. And here is the drawing of your selection. And for this example, you'll notice that it called for a stainless steel casing. So let's go ahead and click this drop down and click stainless steel casing. and you'll see that the drawing is updated to stainless steel. You also have the ability, let's say if you had to fit this through a door, or you're installing this unit in the field, and 37 inches is too tall to fit into my door. What you could do is just click this drop down and click 2, and what will happen is the drawing will update and the selection will update as well, automatically splitting your U-frame into 2 sections, 17.5, 17.5. You also have the ability to modify this top and bottom flange. If you click Modify Top and Bottom Flange, and let's say this example, one of the learning objectives was to put it at 1.25, so let's go ahead and do that, 1.25, and click Update. And you'll see that the drawing updated to a bottom and top flange dimension of 1.25. Now obviously this doesn't change the performance, it's really more for our air handler designers that want to match their cooling coil. They have the ability to match their flange dimensions to better make it fit in your box. Again, we're a custom heat pipe manufacturer, so we don't have standard sizes. We want to make sure that whatever you design fits inside your air handler. So let's go ahead and continue and click Save and Close. And now you'll notice there was another selection here, or another line item, Air Handler 2, that's 5,500 CFM, so it's slightly more airflow, but essentially it has the same entering temperatures and leaving air temperatures. So instead of actually clicking Add New Line and redoing this whole process, what I could do is actually copy this and click Copy To, and you'll see that HU1 is duplicated. This Copy To function, if I check it, I can also copy it to any project that I have in the database. So if I'm designing a similar air handler for another project, let's say another building at University of North Carolina, I could do that by just clicking Copy and then clicking this drop down and looking for that project and clicking Copy To. And when I go into that project, I'll be able to see HU1 already selected and showing up, so you don't have to re-enter data. Now this one is Air Handler 2, so I want to edit this slightly because the airflow is different. So this is Air Handler 2. And the airflow is 5,500 CFM. Now one of the things I didn't mention in the previous example was this drop down where it shows DHP U-frame and DHPF factory install. U-frame is, the only difference is the U-frame is a fully installed or a fully enclosed wraparound heat pipe, similar to the picture you see here on the right, which we ship to the customer or contractor or air handling manufacturer at their factory to slide into their unit when they're essentially installing the air handler, building the air handler. So it's fully enclosed, fully charged, ready to ship and slide right in. The factory install is slightly different. It's essentially the same performance, but it's not fully enclosed. It essentially looks like bare coils. And a factory install means the air handler comes to our factory in Tampa, Florida. We actually retrofit the unit with wraparound heat pipes that do all the metalwork, all the design, make sure everything is sealed properly, and actually ship it out to the job site or ship to wherever location or storage facility that you'd like. So the only difference that you'll notice between the two is the U-frame is a little more bulkier because it's fully enclosed, so the drawing itself is slightly different than what we saw in the previous example. So for this example, the job wants U-frame, so we're shipping this, let's say, to an air handler manufacturer. So let's keep it as a U-frame. The airflow is 5,500 CFM. Let's keep the same fin height, fin length, and hit calculate. And for this one, I'm looking for a reheat temperature of 62.2. 62.2 is exactly what I'm getting. Continue, and save and close. So that copy function is very powerful, in which I only had to select one air handler, and very quickly I was able to select the second one. And then imagine if you had 5 or 6 with similar designs, you can just click Copy To, and it can really speed up and make you more efficient user. You also have this button here called Export Schedule. So if you click that button, hit Open with Microsoft Excel. It's going to be an Excel table, and Excel is opening up right now. And here we go. So we have the wraparound heat pipe that we just selected, AHU 1 and 2, and all the design conditions already tabled out for you. So this is a very effective tool if you're an engineer ready to select and you want to just paste this right into your project schedule for the job. You could do that by just hitting that Export Schedule button right on the selection screen. It'll output to an Excel document for you automatically. So this it's not limited to just 2. You could download it for 10 or 15 air handlers or selections. It's unlimited. It's just going to copy down, and it's a very effective tool and make your process hopefully a lot easier. Now you also have the ability to output reports. So let's say you want to see the design performance just for AHU1. You click this button right here, kind of looks like a bar chart, and click Design Performance, Psychrometrics, and Drawing. That's what I want to see. And here is the design conditions, psychrometrics, as well as the drawing. Now one of the quick bugs, if for some reason you're not getting this screen, one thing that frustrated me early on, I didn't realize my pop-up blocker was enabled. So if this is the first time you're using this software, make sure you have the pop-up blocker enabled. You'll notice probably kind of like an X where your URL is located. And if you click that, it'll say something like allow pop-ups from heatpipeselect.com. Just click allow and you should see this window. For some reason, older Internet Explorer users, this window won't show up no matter what you do for some reason. So what I would suggest is this next thing I'm going to show you in the next 30 seconds on how to output a report. It's kind of a workaround. But for this one, let's say if you want to just output the PDF for AHU1, you can click this drop down. It kind of looks like a floppy disk, and click PDF. A PDF will download to your downloads folder in your browser. And here is a PDF of your design performance for AHU1, AHU2. Now let's go back to the project schedule. Let's go to the previous tab. Now let's say if I have 10 air handlers, do I have to actually click this report button for every single one and then output 10 different PDF documents for 10 different selections? No, you don't have to. And this is the workaround I'm talking about for kind of the older Internet Explorer users. You just click this submittal button and you'll be able to output essentially a submittal or a selection sheet for all the air handlers you have and selections you have in your project. So for this one, I didn't do any bid analysis, which is the economic analysis. We'll do an example 2. So let's just uncheck that so we don't have any blank pages. And you just click Save to PDF. And a PDF will download. This one will take a little longer because you do have kind of more pages, which you'll see in a second. And if you have more documents, let's say if you have 10 selections, that's going to be quite a large selection document because you're outputting it for all 10. So it may take maybe a minute or so to download depending on your internet speed. So you'll see that mine's already downloaded. And here we have the Air Handler 1, Air Handler 2, a combined selection / submittal sheet. So you'll see Air Handler 1, 2, this is kind of the cover page. You'll see the order code decipher, which at the top of every page you'll see the order code, and this is how you decipher that order code. So it's something like fin height, fin length, if you have coding, different things like that. So you have fin height 35, fin length 50, as shown here. Psychrometrics for both, drawings for both. You have details on the electrofin coating that we'll be using, as well as the warranty page. So this is a quick way, it's a workaround for the older Internet Explorer users, as I said, as well as a more efficient way if you want more information, kind of the whole product, all your products that you have selected. Just click that submittal button, save to PDF, and it'll output an entire document. I figure the more, some of this information that may not be needed early on, but I figure the more information, the better. It'll make your customers happy. It'll make your life easier as well with just a click of a button. So let's go ahead and X out of this. I just want to close that, and I want to keep my lesson plan open. And one last thing I want to show you in this example go back into the project. Let's say if you wanted to share this project with one of your colleagues that are currently with the have the software. You could do that by just clicking users, and you can actually add users to your project. So when they log into the software, when they click My Projects, they'll actually see University of North Carolina SC for Student Center. And you can look up users by, if you don't know their username, because this you only can type in the username, you can look up users by clicking the magnifying glass. And let's say you want to share this with my colleague John, the other applications engineer here at Heat Pipe Technology. And you don't know his last name. Let's just say, just type in John. Click John here, and you'll see that every user in the database that has the username John. And you can click John Alfie, which is shown here from Heat Pipe Technology. Click that, and you'll see that HPT John, which is his username, will automatically populate. Click Add New User, and you'll see that when John logs in, you'll be able to see University of North Carolina Student Center right when he logs in. Now, if you want him to make changes, because right now his permission level is only read-only, you could change his permission level by clicking the Edit button, clicking the drop-down, and clicking Project Administrator, and click the Save button. So now when he logs in, not only will he be able to view the project, but also make changes because you've made him a project administrator. Now that's all I want to cover for example 1. So let's go on to example 2. Let me open that PDF. Example 2. So here we just have one air handler. I have the job name Georgia Tech Student Housing, where I have see attached info for 100% outside air or 100% air handler unit that needs to provide 68-degree air year-round. I would like to add a wraparound heat pipe to this unit to limit my terminal reheat. So this is an application where they're using some form of reheat because they want to try to maintain around 68 degrees year-round. Here is my technical data for my air handler, as well as I have the drawing on the next page. So here we have the entering air, 95.75. The temperature leaving the cooling coil, 53.5. I also have the fin dimensions, 39.61, fins per inch. So I have all my info here, as well as the airflow, 5,200 CFM. So let's go ahead and create a new project. So go to My Projects, and type in GT Student Housing. Click Add New Project. Let's just say Waldorf Dorm. Just made that up. Project type, Educational Colleges, and click Update. So again, GT Student Housing is populated. You'll also see University of North Carolina, which we worked on previously, is shown here still. To open up GT Student Housing, let's go ahead and click the Schedule button. Click Add New Line. Now to start your selection, again, you want to click the Select Item button. For the tag, this one was HU1, technical data, so let's tag it as HU1. Correct, HU1, yes. Fin height 39.61, airflow 5,200, 95.75. So this is an example where I want to do controllable. So for this one, I'm going to do non-controllable, and let's see what happens. I'm going to say HU1 NC for non-controllable. Fin height is 39, fin length is 61, airflow is 100% outside air, 5,200, 95.75. Temperature leaving my cooling coil is 53.5. And let's hit Calculate. And here we go. We got an error message here that I purposely did. It says fin height must be in multiples of 1.25. You can either enter 38.75 or 40. So that is actually the distance from center to center of our fins. So the fin height actually has to be in multiples of 1.25. So for some reason, again, this one we enter 39 because that's what the cooling coil is. So to keep it simple, let's go ahead and put 38.75, and that error message should go away. And you'll see that I'm taking 95-degree air, cooling it down, 81, about 14 degrees of pre-cool, which is really nice. from 55 heating up to 68.9, which is exactly what the engineer is looking for. However, the key word is he's looking to hit around 68 degrees year-round to limit my terminal reheat. So let's see if we do that year-round. So we could do that by just clicking Economic Analysis. And the first step you want to do is click the location. So this is Georgia Tech's located in Atlanta. So let's click GA and Atlanta. Hit Apply. So that's the first step you do. You also have the ability to enter the hours runtime. So let's say this is really nice. This wasn't in our old software. So you have the ability to, let's say if you're designing it for a school or an office building that has kind of a limited occupied hours, so you want to get very exact savings. So let's say if it's for a school, you could deselect May, June, and July. So you don't have the air handler or the heat pipe savings shown for May, June, and July. But for this example, let's keep 24/7 and let's load the bin data. Once that bin data is loaded, you'll notice that the outside air is only shown at the top. So at the top, you'll see that it's 5200 CFM and the temperature leaving your cooling coil at 53.5. Now to copy that, so I don't feel like typing into all the remaining rows, what you could do is just click the duplicate row button. And this will actually copy that airflow as well as the temperature leaving the cooling coil to all your remaining rows. And the next thing you want to do is click Calculate Economic Analysis. So here's your economic analysis screen. This is kind of your savings summary. So you can select your reheat. Let's keep it at electric, 8 cents. You can also select hot water, gas, fuel. So let's assume for this job they're actually using electric reheat, which is the most expensive. We'll keep it at the default of 8 cents, but you could change that to 10 cents if you'd like. Let's put 10 cents. And you could change the ER, fan motor efficiency, fan efficiency, as well as the burner efficiency. To calculate the savings based on 10 cents kW, hit Calculate, and here are the savings. So you have your total pre-cool savings for Georgia Tech at around $1,300, reheat savings around $5,600, the static cost, which is actually going to be a negative, because really the only true cost of the wraparound heat pipe is the static cost of essentially the fan power losses, because you're adding 2 coils to your wraparound. So you're going to need a little bit more of fan power to push that air through the 2 additional coils. But again, this being a 2-row is not that bad in regards to pressure drop. You're only losing $170 a year. So your total net energy savings for this example is $6,700. For the overall cost, let's say this cost me $10,000. Hit Calculate. You'll see that there's a payback of 1.5 years. You also see this thing called recovery efficiency ratio, which is 226.32 BTUs per watt hour for this example. And you actually can read more about this function in ASHRAE Guideline V. It's essentially a ratio in which it captures, it's kind of a measure of efficiency for an energy recovery device, where it takes year-round, for this example, all the energy you recovered for your energy recovery device in BTUs, and it divides it by what the actual energy you use to recover that energy. So in our case, it would just be the fan power. So we would actually take all the energy we recovered and saved and divide it by the fan power year-round. So that's kind of the watt hour that you see in the denominator. So for basically what this is saying, that for every watt hour that you use, this wraparound heat pipe is giving you 226.32 BTUs, which is pretty amazing, because you're getting double, because you're getting pre-cool as well as reheat as well. So let's go ahead and click Continue and click Save and Close. Now to output a report, because again this engineer is looking for year-round energy savings, click View Report and Bin Analysis. And here is the report. So here is where you'll see all your energy savings. So your outside air, return air, in this case was 0. Pre-cool heat pipe, it shows that you're taking 95 degree air, cooling it down to 81.2 or 82 basically, and it's so on and so on. And obviously in the winter months where the heat pipe is not doing anything, you'll see that the savings is shown as 0. Now for the reheat heat pipe, you can see at all those outside air conditions, where am I actually getting around 68 degrees? So on my design condition, I'm actually getting 69.2, which is pretty nice. A little less than that, I'm getting a right at 68, but then I'm dropping down to 66.4, 64, 62, 61, 59.6. So in these cases, at your part load conditions, I'm actually having to use terminal reheat. So I'm not really getting that year-round recovery that I'm looking for. So one kind of an application or design method that you could do, since we do offer controllable wraparound heat pipes, is kind of a method of what we call oversize your wraparound and add control valves. Because what it's mainly done is people tend to actually design their wraparound just to hit for their design conditions. But if you look at your part load conditions where you have the majority of your hours, it's better to design your wraparound to hit that at those conditions, because that's where your savings are, at your part load conditions. And what you could do is just click this copy to function that we learned in the previous example. And let's call this, let's change this to HU1C for controllable. And let's make it a controllable. Let's say it's, let's give it at 120 volt. We normally open valves either 24 or 120. And for the stages, we group the valves into stages. So if you have, let's say, 16 valves, we'll group 4 of the valves if you select 4 stages into one stage. So you'll have 25, 50, 75, and 100% control. And to oversize, let's go ahead and use the number of rows, 4 rows, and hit calculate. So you'll see on my design condition, I've oversized, so I'm exceeding at my design. So the engineer is only looking for 68, but at my design condition, I'm getting 72.76. But now let's look at the economic analysis. Let's go ahead and click calculate. Everything's already there for you. And here is the savings. So the savings is obviously going to be higher. You now have around $8,500 in savings. Now let's say this system is double. Let's say it costs $20,000. Hit calculate. Now it's gone essentially double the payback, 2.4 years. Now let's continue. Let's look at the actual bin analysis. Save and close. And click bin analysis. And you'll see that tab opens up. And here is an oversized 4-row controllable wraparound heat pipe. So now you'll see that I'm at design, I'm at 73.1. So what I'll do is I'll start scaling back performance. 71.5 at the second. I'm still not using any terminal reheat. I'm still not, really still not. It's really only when the outside air temperature is around 82 or 76 degrees is where I'm actually starting to use some sort of terminal reheat. Whereas all the other, and again, that's less terminal reheat than the 2-row example. So I've essentially designed, oversized my wraparound heat pipe to basically hit my design or my terminal reheat condition more at my part load conditions rather than just focusing at my design conditions. So that's one example that you could do and run through by just seeing what happens with a 2-row, and then let's say going up to a couple rows higher but make it controllable, especially if you're looking for year-round recovery at your part load conditions. Because again, what drives a wraparound heat pipe is the temperature difference between your outside air and the temperature leaving the cooling coil. So as that outside air goes down, even though your cooling coil is going to stay about the same, your temperature, your actual heat pipe performance is going to go down. So at part load, you really want that extra rows to get you that extra recovery for that extra savings year-round. So that's kind of what I wanted to talk about for example 2. Now let's go to the last example of the day, which is example 3. I have Tampa High School shown here, and saying the email says we are having humidity issues at a local high school. See details below. We have a DX system looking to get further dehumidification. So this is an existing unit. I believe dehumidification heat pipes might offer a solution. I would like to see both a 1- and 2-row wraparound option. So he tells me a little bit about his air handler. I have an airflow of 7,500 CFM. My face velocity is 450 feet per minute. Leaving air temperature 58.2, 57.4, which is probably why he's having humidity issues. His air handler wasn't sized properly. He's looking at, looks like what a 50-ton system, a DX system. So let's go ahead and run through this example. And I'm going to show you an example for a DX system so you can actually, the program will actually calculate what the new leaving air temperature will be when you add a 1 or 2 row wraparound heat pipe. So let's go ahead and do that. Let's go back to the software. Click My Projects, and let's type in Tampa High School. And click Add New Project, and click Update. Click Add New Line. Here's the Select Item button. For my fin height, let's type in fin height 40, fin length 60. He doesn't really tell me that dimensions, but I do know the airflow velocity is 450 feet per minute. The airflow is 7,500 CFM, so I kind of can figure out what the approximate fin height, fin length would be. Now, for the airflow, just type in 7,500 CFM, the dry bulb 91, wet bulb 79. Now, for my cooling coil output, instead of clicking temperature, let's go ahead and click fixed capacity, because I know it's a 50-ton unit. So I just take 50 ton or times 12,000 BTUs per hour. I get a 600,000 BTUs per hour system. And now let's go ahead and click calculate, and let's make this a 1 row, tag this as 1 row, and click calculate. So now what's happening is the program assumes you still have that same 50-ton capacity, which is shown here, but now you've added a wraparound heat pipe. So with the cooling coil before, it was leaving at 58.2, 57.4. You've essentially shaved off 2 degrees by adding a 1 row wraparound heat pipe with only adding about 0.2 degrees or 0.2 inches of pressure drop to your system. So you're cooling down from 91 to 84. So instead of your cooling coil seeing 91, now it's only seeing around 85 degrees. And now you're getting even, again, further dehumidification. And you're leaving the reheat heat pipe at 62.1. So you're leaving at a not only more dehumidified, but a slightly elevated temperature air, but it's further dehumidified. You can go ahead and click continue, because I want to see what the 2 row gets me down to. Click save and close. Copy to. And now let's change the selection. I'm going to change this tag to 2 rows. Click 2 rows. Again, I'm going to keep the same 50-ton system. And now check this out. So now the cooling coil, instead of leaving at 58.2, I'm now leaving at 53.64. So I'm really pulling out a lot more moisture. You can already see it here, 351 pounds of moisture that I'm pulling out by just adding a 2 row wraparound heat pipe. Now for this example, the 1 row added about 2 inches, a 0.2 inches of pressure drop. This is adding about 0.4 inches of pressure drop. So that's obviously something you want to consider as well. But this is a simple thing that we do quite often where we have existing equipment in the field where the customers are dealing with humidity issues. And what we could do is we can add a 1 or 2 row wraparound, assuming obviously that air handler has enough space upstream and downstream of the cooling coil, and actually allow the current air handler to basically better dehumidify by reducing the load on the cooling coil with the pre-cool heat pipe. So that's one interesting application that we see quite often, where you can essentially downsize your equipment by adding a wraparound heat pipe. So maybe going from a 50-ton unit down to a 45-ton unit by just adding a 2 row wraparound. It'll allow you to be more cost efficient, as well as it makes the overall system more energy efficient as well. So let's go ahead and click continue and save and close. So that is actually the last example that I want to show you today, to both the 1 and 2 row wraparound examples for example 3. Now example 4, which is I call the just for fun example, I encourage you to, again, download this document and take it home with you And basically it's an example in which it kind of challenges the theory that the wraparound heat pipe is really only for systems for 100% outside air systems. If I have a 100% return air system or a mixed air system, the wraparound is not going to work as well. So what I want you to do is actually challenge that theory. I want you to actually design a system that's 100% outside air and run an economic analysis based on these inputs here, as well as run a 100% return air example and use your location and see which actually has the better savings. And I think you'll actually be surprised by the results. So go ahead and try that example when you're home. Send me an email if you do have any questions. You could do that by just going to Cyril, C-Y-R-I-L, which I'll show here in a second, at heatpipe.com. And I'll be interested to see if, obviously, if you run into any issues, and just let me know the results. I'm very curious to see in your particular region which actually produces the best savings. And I think you'll actually be surprised by the results. Again, I want to thank you for the time that you've taken out of your busy schedules to attend this webinar. Here's my contact information if you do have any questions, or you can reach me directly at 813-906-3175. I'm also the project administrator or project manager of the design software. So if you do have any ways or have issues or have ways that we can improve our software, which again we're trying to do on a monthly basis, just send me an email, send me your comments, and I'll be happy to take those under consideration and make those improvements. Because we want to make the software as user-friendly as possible, as well as have the ability to customize it for your particular application and make it as easy as possible for you during your selection process. I'll leave the last 10 minutes of this webinar for questions. So go ahead and add your questions in the comment section. I'll go through it one by one. I'll stay as long as you need me to. But for those who have to go, I understand. And I thank you so much for attending. Here's where I'll leave it open for questions. Thanks again.